Hi, welcome to Unit 3, Models of Earth. The globe, as you know, is round. And this unit we're going to talk about how we represent that round Earth on flat pieces of paper. As you know, globes are three-dimensional models of the Earth. But imagine trying to take an orange, peel it off, and spread it flat on the table in front of you. It's going to be distorted looking. There's a lot of different types of maps. We use maps for so many things. There are political maps, which just show you the names of the countries. Notice how distorted Antarctica is at the bottom. We'll get to that in a minute. There are road maps, which show interstate systems, highways, smaller roads, and we use them to get around, although most of us have that Google Maps on our phone now. But here's an example of a road map of Virginia. There are weather maps, which of course we do use in science. They can show pressure systems, the cloud cover, the amount of rainfall, and of course weather forecasts, which we're always interested in. So here's a typical map showing low pressure, which is usually related with storms moving up into the northeast. And you can see if there's a color key to tell you about precipitation. There are bathymetric maps, which are the seafloor, which is something else that we use in science classes. It can show you the features on the ocean floor, the temperature differences, which this one shows, not only just temperature but age of the seafloor. And then there are topographic maps, which will be a subject in this section. Topographic maps show you the differences in elevation of an area, and it also shows you man-made features. Here's a typical look at a topographic map. This is Salt Lake City, so there's streets on it, but there's also little tiny brown lines on the surface that indicate elevation, and that you'll be learning in this section. So paper maps are flat two-dimensional representations of Earth's surface. The problems with them are you can't be as accurate as a 3D globe model, which represents the true shape of the planet. Earth's features become distorted and they don't look right. For map making, surveyors use distance and elevation information from known points. There are known points in the ground many places on this Earth, and they're called benchmarks. If you have hiked any of the mountains around the Phoenix area, you've probably come across a benchmark at the top of Camelback Mountain or Squaw Peak. Aerial photography also helps map makers. Here's a couple pictures of benchmarks. These happen to be in Hawaii. This is what the land surveyors used to look like. They were out traipsing around, walking the landscape, surveying it, and trying to make maps of the surface. Modern surveyors have much better equipment. They can use compasses, infrared theodolite, and then GPS, which is satellites, to look down at the planet. Maps are projected then onto pieces of paper. A cartographer is a person who makes maps. A map projection is what we call it when you transfer the Earth's surface, which is curved, onto a flat piece of paper. So there are three types of common map projections. There's the Mercator projection, the gnomonic, and the polyconic. Notice gnomonic also is called polar. The Mercator projection map is probably the most common. This is a projection that shows the Earth as if a large cylinder of paper had been wrapped around the globe. And like I said, it is the most common type. So here's a Mercator projection of the Earth, and notice the distortion. The Antarctica continent is not that large, and nor is Greenland that large up above the United States. So here, let me put my arrow on Greenland. But it's very good for the middle latitudes because they're not distorted as much. So the disadvantage, again, is distortion. But the advantage is that it indicates true directions as straight lines. And it does make a rectangular grid pattern. The second projection we'll look at is polar or mnemonic, and it's created as if a piece of paper had been placed on a point on the Earth. So for example, this map is Antarctica. So this is looking down on the Earth, and Antarctica is not distorted, but as you go away from it, there's more distortion. And then here's a polyconic projection, which is pretty good for the middle latitudes too. So it's a view as if a large cone of paper had been wrapped around the globe. So you should be able to identify these types of map projections. So if you need to do a sketch, but write the names down in your notes. What type of halves is the Earth divided into? Well, let's look at that. There's the northern hemisphere and the southern hemisphere, and they get separated by the equator. And there's an eastern hemisphere and a western hemisphere that are separated by an imaginary line called the prime meridian, which runs through Greenwich, England, and the international date line, which is the line on the opposite side of the Earth. We'll have a lecture about using the hemispheres and the coordinates we call latitude and longitude.